I would like to welcome everyone to my presentation. Um, so our topic for this morning is about cloud computing and edge computing, and what's the difference between cloud computing and edge computing. If you might notice, the title is cloud or edge. It's because we should not be comparing cloud versus edge, as it is one function for one ecosystem. So wait, let me just stop my video camera. All right. So what I'm going to present right now is the understanding of the network environment through my journey as an IT professional. So this is my 15 years experience with programming. Started with started with the typical uh, on-site deployment up to the cloud computing and going beyond the edge computing. So let me introduce myself again. My name is J.R. Alvarez. Actually, John Romero Alvarez is my full name. You can call me J.R. Alvarez. I'm the CTO and co-founder of Codeworm IT Solution. Uh, I am a cloud solution specialist, so I've been developing application and ecosystems on cloud premises. I'm an active social civic volunteer, so I am actually part of the Fraternal Orders of Philippine Eagle. So I've been volunteering for the past 1 year already. And on my free time, I play airsoft. So my LinkedIn profile is there below. You can check it in. So actually, my journey starts 16 years ago. So I've been in the industry for a solid 16 years experience, and I've started as a systems analyst from a company named CTI, and it is now called CTL. So this company is actually connected with uh, three major telcos. When I was there, three major telcos, which is the Smart Telecommunication, Globe, and Sun Cellular. So we're doing loading transaction from a dealer's endpoint and a retailer's endpoint up to fulfillment. And then from that experience that I have, I've been pioneering backend applications for this company, and up until now, they are running and rendering actually my services as a consultant with them. So back then, we have our servers on a data center. So we have data center on Vitro in Pasig, C5 Pasig. Uh, that's where our application is deployed. And going to that experience in going in a super strict and super tight security premise, it's one of a quite an experience that I have, because it is a privilege to visit this facility and see how a collection of computers, servers, and running as one. So as you can see, from that point, we already have an idea of how this journey will going to evolve. And then after working for CTL, I have a short stint as a front end web developer for an e-commerce site in the US. And then we've developed applications on cloud. Actually, it is deployed on a cloud server on the Demandware. Demandware is the application that we are using, and it is deployed on a cloud server that is based on Texas. So this is my first engagement with cloud computing. And after my short stint with the company, I've joined Point West way back 2010, and I would say the local company Point West that where I've been hired as a software engineer have clients for an outsourcing client for various what do you call this industry. So I've been deployed on projects for a medical technology, I also I was deployed with Financial, if you're familiar with Visa International. So I've been developing applications for them. We airlines, of course. We do have airlines, and then lastly with media entertainment with 20th Century Fox, which actually what we call now as Disney, because they purchased it by the time that I was there. From my stint with Point West, I have handled different roles, such as software engineer. So as a team lead, I've also handled software architectures and then a cloud specialist lastly. And then there are certain small parts of my role, like a software developer trainer. So I've been training software developers for Point West on their boot camp. So I've been a trainer for almost 3-4 years already, and other various roles depending on what is needed by the organization. During my stint with Point West, that's where I got the in-depth knowledge with cloud computing. Me being a Microsoft tech savvy and actually a biased Microsoft practitioner, I gained a lot of experience with Azure cloud services. And in my own assessment, I think I'm doing great. And creating architecture, software designs on various applications, and fully utilizing cloud computing capabilities with microservices and clean architecture approach. And I've been pitching, software designs and ideas, which includes cloud services, and its capabilities and benefits with the end user. So let's just watch this video from AWS. If you're wondering why AWS, but I'll explain to you later. Let me just play this one. Let's watch this.
Cloud computing is the on-demand delivery of IT resources via the internet, with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases on an as-needed basis from a cloud provider like Amazon Web Services. Organizations of every type, size, and industry are using the cloud for a wide variety of use cases, such as data backup, disaster recovery, email, virtual desktops, software development and testing, big data analytics, and customer-facing web applications. For example, healthcare companies are using the cloud to develop more personalized treatments for patients. Financial services companies are using the cloud to power real-time fraud detection and prevention. And video game makers are using the cloud to deliver online games to millions of players around the world. With cloud computing, your business can become more agile, reduce costs, instantly scale, and deploy globally in minutes. Cloud computing gives you instant access to a broad range of technologies so you can innovate faster and build nearly anything you can imagine. From infrastructure services such as compute, storage, and databases, to Internet of Things, machine learning, data analytics, and much more. You can deploy technology services in a matter of minutes and get from idea to implementation several orders of magnitude faster than before. This gives you the freedom to experiment and test new ideas to differentiate customer experiences and transform your business, such as adding machine learning and intelligence to your applications in order to personalize experiences for your customers and improve their engagement. You don't need to make large upfront investments in hardware and overpay for capacity you don't use. Instead, you can trade capital expense for variable expense and only pay for IT as you consume it. With cloud computing, you access resources from the cloud in real time, as they're needed. You can scale these resources up and down to grow or shrink capacity instantly as your business needs change. Cloud computing also makes it easy to expand to new regions and deploy globally in minutes. For example, Amazon Web Services has infrastructure all over the world, so you're able to deploy your application in multiple physical locations in just a few clicks. Putting applications in closer proximity to end users reduces latency and improves their experience. No matter your location, size, or industry, the cloud frees you from managing infrastructure and data centers so you can focus on what matters most to your business.
Watch previously, you might want to ask why I presented AWS, though I am a Microsoft tech savvy or a Microsoft developer. The thing is, there's really not much different with the process that they are doing for every cloud services or cloud service providers that we have. They have the same infrastructure architecture. They have the same ecosystem. The difference is how they deliver the service and how efficient they are delivering this service. So as per you have watched, cloud computing is an on-demand delivery of IT resource over the internet. So you can do a pay-as-you-go pricing, or you can do a what you call a steady or on-demand standby pricing scheme. So instead of buying your own machine and owning it and then physically deploying it on a data center, so remember what I have discussed earlier from my first company, we do have a physical server on a data center in Vitro, and we do manage those servers. And we constantly, we constantly update and upgrade this server in cases we needed. Not just the server, we also provide with the security for the firewall, security for our own system, the antivirus systems installed, and then the communication itself. What we are worrying, what the data center provides is an accessible 24/7 online accessibility. So there is no there is a downtime, though the downtime is between 0.3 to 0.5%. And in most cases, they have redundancy. So if there is, let's say, power interruption, a backup generator will run. So let's say a connection from the internet was cut, there is another redundancy for the internet connection. So the data center manage that, but we manage our server and the health of our server. With cloud computing, we don't actually need those server, but we just need to access the services that the cloud provider is providing. For this example, we have the AWS, which is providing cloud computing services. All right. So who actually is using cloud computing? So cloud computing is being used by organizations of every type, of every size, of any industry. There's a wide variety of services that can be utilized with cloud services. With the software development that has been happening right now, and the evolvement of our technology, there is actually a increased number of usage of cloud services, and most of the applications that we are using right now has been connected in cloud. So who amongst this organization and what they are looking for on a cloud service? So we have the top 5 reasons why they are using cloud computing. First off is a data backup. Data backup, wherein the information that they have, the database that they have stored on their let's say on their physical server, can be migrated into cloud services. With that, they have a backup copy of their data that is residing in cloud. So in any case, the server that they have on their own premises or their own data center suddenly corrupts, and then they cannot retrieve those. They already have backups on the cloud service. Other company or organization is looking for the disaster recovery. So disaster recovery is something that is very important for an organization, especially when there are uncertainties on their operation with, let's say, natural calamity that happens. So they do have a disaster recovery plan that is planted on a cloud service, and then they can access it anywhere. Other organization is using virtual desktops or virtual machines. So they can end users from their organization can do remote access using virtual desktops. Others do the big data analysis. So if they have chunks of data that is too large and too many to handle by their server, they can deploy it on cloud services. And mostly software developers. So software developments are putting in their source code on cloud. If you're familiar with Azure DevOps or GitHub or GitLab, so or Bitbucket, it's actually a cloud service wherein any developer that has an access to that cloud service repository can push their change to that cloud service, and anyone else from their team or their organization can pull those change and apply the change that they have and push it back to the server. That way, the collaboration between the team, even though they are remote, is on sync. So that's the top 5 reasons why organizations are looking for using cloud services. So what are the benefits of cloud computing? Actually, tailor fitting the needs for your organization will benefit on your cloud computing. So we have the agility. The cloud gives you access to a broad range of technology, so you can innovate faster and build nearly anything that you can imagine. So let's say you can have an ecosystem wherein you have Linux server that is running, and then you have a Windows application that is also running on a different virtual machine. Although they are within the same ecosystem, they can work through as one ecosystem. And then we have elasticity. So elasticity is actually wherein cloud computing will help you do the provision over your resources. So if, let's say, for example, your transaction for the day is peaking on thousands of records for a certain hours, let's say for 9 to 12 in the morning, you're peaking at 1,000 to 5,000 transactions per second. You can provision your cloud services to handle this peak, this transaction by scaling out or scaling up to meet the required provision, so that end users or end consumer will not be affected. And in times that the transaction is peaking down, or let's say there's not much of the transaction, you can scale it down or scale it out based on the required need. Next is cost saving. Actually, cost saving is tie hand in hand with elasticity. So if you are using cloud services and you are expanding and scaling it out, it will have additional costs. But then again, you're just accruing costs based on the peak hours that you have, and then you can reduce that cost whenever you need it. So it's on demand. You can have it automated. You can do it manually. But again, this is on demand and real time. Okay. So lastly is the deployment. So benefits of deployment, again, what I've mentioned earlier with software developers, being a team that is working on a cloud service on a remote area, collaborating on one project. They can do that with cloud computing, and it's actually easy to deploy. And it can be in any region, in any geographic region in the world. They can deploy it globally in minutes. So what are the types of cloud services? So there are three main types of cloud services. So first off is software as a service. Software as a service provides you with a complete product that runs and managed by the service provider. In most cases, people are referring to SaaS and are referring to the end user of the application. So for example, we have our webmails, we have our CRMs, collaboration or ERP. And then with SaaS offering, you don't have to think about how the service is maintained or how the underlying infrastructure is managed. You only need to think about the software itself. Next is the PaaS, which is platform as a service. So platform as a service removes the need for you to manage the underlying infrastructure. So you don't need to manage the usual hardware and operating systems underlying ecosystem on that, and then allows you to focus on the development and deployment of your application that you are going to manage. This helps to be more efficient, as you don't need to worry about resource procurement, capacity planning, software maintenance, patching, and other under-related heavy lifting involving running your application. Lastly, the last type of cloud service is infrastructure as a service. So infrastructure as a service, or IaaS, contains the basic building blocks for cloud IT. It's actually typically that provides the access to the network feature. It provides you the computer, virtual and dedicated hardware, and data storage and space, and other networking services. IaaS gives you the highest level of flexibility to manage and control over your IT resource, and most similarly to the existing IT resource of many different IT departments and developers that are familiar. Okay, so let's review. What is cloud computing? Again, cloud computing is an on-demand delivery IT resource over the internet. It could be an infrastructure as a service, it could be a platform as a service, or it could be software as a service. Who is using cloud computing? So organizations of every type, or any type or any size, can use cloud computing. What are the benefits of cloud computing? Cloud computing has the ability for its agility, gives easy access, elasticity, where you just need to use what you need, cost saving, which is the pay-as-you-go payment scheme, easy deployment, so you can deploy it everywhere. And the different types of computing is, like I've mentioned earlier, is the infrastructure as a service, platform as a service, and software as a service. So with that actually information in mind, this information that I have gathered through the course of working as a software engineer, may it be on Azure or AWS, it's actually a benefit that will bring the end user satisfaction that you need to think of. And with that, I have created with that information, I have created several designs of the application. I do have a software development application that is designed based on the Microsoft eShop architecture. And it's actually utilizing Azure Cloud Services. So we have the app services, the service bus, the API gateways, CDN, different databases. And we also have the containerization using Docker. So we have Docker for the containerization, and then we have orchestration with the likes of Kubernetes and Service Fabric. And there are tons of and different services from the cloud service to choose from, it's actually so large that we cannot fit every services into one session itself. So what I am presenting to you right now is we're just scratching the surface of cloud computing. So one in particular, I do have an application that we are managing 9 million records, and we need to sanitize those records. We need to sort it, we need to filter it, and then we need to transform it. And it is required by the end user to be displayed within 10 seconds. Yes, we were able to achieve this, and yes, our end user are very satisfied with the result. So much so that they incorporated additional information, additional records, and they want it to be presented in a graphical way. And with that, every time the data grows, every time the computation grows, we scale up our services to compensate with the performance that is required to do the transaction, up to the point that we reach our spending limit, that we need to resort on different strategy in transforming the data. So in short, in every change and move that we did on cloud services, it will really cost you money. So and that cost is not cheap. So in that scenario, we've been introduced with edge computing. So what is actually edge computing? Let's watch another video.
What is edge computing and why it matters? Edge computing is exactly what it sounds like, computing that takes place at the edge of corporate networks, with the edge defined as the place where end devices access the rest of the network, things like phones, laptops, industrial robots, and sensors. The edge used to be a place where these devices connected so they could deliver data to and receive instructions and download software updates from a centrally located data center or the cloud. Now, with the explosion of the Internet of Things, that model has shortcomings. IoT devices gather so much data that the sheer volume requires larger and more expensive connections to data centers and the cloud. The nature of the work performed by these IoT devices is also creating a need for much faster connections between the data center or cloud and the devices. For example, if sensors and valves at a petroleum refinery detect dangerously high pressure in the pipes, shutoffs must be triggered as soon as possible. With analysis of that pressure data taking place at distant processing centers, the automatic shutoff instructions may come too late. But with processing power placed local to the end devices, latency is less, and that round-trip time can be significantly reduced, potentially saving downtime, damage to property, and even lives. Even with the introduction of edge devices that provide local computing and storage, there will still be a need to connect them to data centers, whether they are on-premises or in the cloud. For example, temperature and humidity sensors in agricultural fields gather valuable data, but that data doesn't have to be analyzed or stored in real time. Edge devices can collect, sort, and perform preliminary analysis of the data, then send it along to wherever it needs to go, to centralized applications or some form of long-term storage, again either on-prem or in the cloud. Because this traffic may not be time-sensitive, slower, less expensive connections, possibly over the internet, can be used. And because the data is pre-sorted, the volume of traffic that needs to be sent at all may be reduced. So the upside of edge computing is faster response time for applications that require it, and slowing the growth of expensive long-haul connections to processing and storage centers. The downside can be security. With data being collected and analyzed at the edge, it's important to include security for the IoT devices that connect to the edge devices and for the edge devices themselves. These devices contain valuable data, but there are also network elements that, if exploited, could compromise other devices that contain stores of valuable assets. With edge computing becoming more essential, it's also important to make sure that the edge devices themselves don't become a single point of failure. Network architects need to build in redundancy and provide failover contingencies in order to avoid crippling downtime if a primary node goes down. The industry has already gone a long way toward addressing the demands of edge computing, and it's becoming mainstream. Its importance is likely to grow even more as the use of real-time applications becomes more prevalent.
From the video that we have, edge computing is a process of computing of client data closer to the data source rather than on a centralized server or a cloud-based location. At the simplest form, edge computing brings computing resources, data storage, and enterprise application closer to where people consume this information. So from that point, any data that is on the every data is the core of any function or functioning business. Over the years, this unprecedented volume of information and computing power and connection to the devices have accumulated vast amounts of data and causing massive strain on the already congested internet. So this massive accumulation of data leads to bandwidth latency issues. And unlike traditional enterprise computing, where data is produced at the client's end or the user's computer, edge computing offers a better alternative to move away from the managing complex data to close proximity on an original data source. As you would see that from the slide, the edge computing architecture, wherein there are three main layers. We have the cloud layer, which is processing the data and getting the processing the big data, and then they have data warehousing. The second layer have the edge layer, which is data processing and reduction, data caching and buffering, control response and virtualization. It's been redundant with different edge servers or edge nodes or components. And then we have the device layers. It could be a sensor, could be a camera, it could be the GPS itself, it could be your computer or any IoT devices or mobile phones for simpler purposes. So we have these components of edge computing. We have the Internet of Things, which is the physical object with sensor, processing ability, software, and other technologies that connect and exchange the data with other devices and system over the internet. The communication network, which is the communication between your devices or your device components to the cloud computing, which is the last component for the edge computing. So it is an on-demand availability of computer system without direct active management with the user. Okay. Next is all right. So these are the different use cases for edge computing. Before we go to the edge computing versus cloud computing, so we can use edge computing on manufacturing. We can use edge computing with oil rigs, mining, and gas industry, financial services. We can do it on healthcare. Can do it on retail, autonomous vehicle, gaming, smart cities, and video streaming. So going to the left side, which is the edge computing versus cloud computing. So this is where I mentioned earlier that we should not be comparing edge computing and cloud computing. Edge computing has the benefit of low latency, reduced backhaul, and data localization, whereas cloud computing has the benefit of scalability, mobility, and light devices. If we use both edge computing and cloud computing on our infrastructure, then we are a hybrid IT environment where we can benefit with low latency and yet scalable. We can reduce the backhaul and yet it is mobile. We have data localization and yet we have cloud service wherein we can store massive data from any point of the world at any point. in any area. So we actually I got this what do you call this article from Spicework, wherein they are explaining how Edge and 5G can unlock the true potential of AR and VR. So if you're familiar with artificial augmented reality and virtual reality, so it's been growing constantly. So not just for gaming, it's actually more on that. We are going beyond what we are doing on gaming with virtual reality. If you will notice on the healthcare service, how do surgeons do the how the surgeons train with the surgery that they have, how they're going to perform. It is mostly because of uh virtual reality. So they have a system wherein doctors can be on a VR goggles, and then they have their controllers, and then looking through the uh, the surgery on what organs to look at, and what nerves to look at, and what is the purpose of their surgery, without the expense of having a patient lying on the bed, and then the doctors doing their study from that. So it's actually with the help of VR that we have those amazing surgeons that we have right now. The difference between AR, augmented reality, and virtual reality is not that much, but on the augmented reality, it is combining the motion picture or automated image on the actual screen that we have, actual place that we have, and then augmenting it on our different things. Let's say if you're familiar with the dinosaur or the animals that is being augmented on social media platforms. So they do have that. On the VR is immersing yourself to the virtual reality itself. So everything you see is virtual reality. So what's the capability of 5G, or I mean what's the benefit of using 5G on AR or VR? So if we can transmit information using the 5G network faster and more reliable, then augmented reality and VR can be of potential use. So it on AR and VR, they need to be they are in constant communication with their end server. So this is where the edge is coming from. So any information that is stored between the end user and communicating using 5G through the edge computing, then the edge computing doing the processing, the computation, and then sending it back to the user, and then sending the information up to the cloud. So if the communication between them is 5G, then there's a potential wherein VR and AR can be applied in other industry as well, not just on healthcare. Although there are other VR services that is happening right now. I guess there is a augmented reality for architecture, wherein you can patch in walls, you can put in sofas, you can put in lamps on your plain sala or living room, and then see what best fit without purchasing the actual appliances. So with that we can see the potential of AR and VR, 5G and edge, with cloud computing and edge computing. So edge cannot take over cloud. So edge cannot take the role of a cloud, but together they enable or improve performances for end user. Additionally, it still depends on the client's demand and expectation for the ultimate user experience. Different situation can call for a usage of edge computing, whereas other would benefit from the use of cloud or hybrid system. With all of this understanding, your end user should be your ecosystem's primary driving factor. So from that, let me go back. So from this idea that we have regarding edge computing, the application that we're going to build can be deployed in an edge computing service. Since we are handling millions of records, and those records are actually sorted and separated by region, so we can specifically say that we have a cloud database that have the millions of records. Then we have the edge computing, wherein it is doing the processing, the sorting, the managing, the transformation of the data. And then from the end user, it's just accessing the edge computing from that point. And then we can still meet the user's expectation to display the record within a 10-second limit. Though the pandemic hits and everyone is forced to work from home, or if not laid off, I was one of the few fortunates that keep on working and doing freelancing activity as a side hustle. As we moved back in Batangas to escape the crowd of Metro Manila, only to find some IT graduates here that is not working on the IT industry. Some even got laid off because of the pandemic. Some cannot get their meat ends. Then my wife and I got this idea for a startup business that with the help of with helping individuals learn software development for free. We do it for free. We help them get on their feet and land a freelancing job. We were able to train a few. Then we slowly then the market actually slowly going back, and some of the persons that we trained are doing came back to their regular jobs. Some wanted to continue with their side hustle with software with web designing, and actually our advocacy that that we will continue to train and retool those who wants to learn software development. And not only that, we will strengthen the IT community, but we will strengthen our IT community starting from our own locality. So a few takeaways from my presentation. So business, as we all know, is undergoing seismic transformation thanks to edge computing. It's an intriguing possibility that offers greater chance of unleashed potential of data. While centralized cloud have a long been and preferred choice, edge computing is a way of the future. Enterprise may develop autonomous system, speed up to responses, save time and money, and gain deeper insight by embracing life at the edge. It provides new opportunity for improving customer experiences in different industries, may it be on factory, productivity, may it be in retail and entertainment, in healthcare. It doesn't matter. In fact, edge computing is rapidly developing technology that is ushering a new era for the data analytics. So that's it for my presentation. Thank you for your attention. And here's my contact details if ever you want to get to know me. And thank you very much.
Still valid the concept of fog cloud beside core edge.
Sorry, what's the question again?
Is still valid the concept of fog cloud beside core edge?
Fog cloud beside core and edge. All right. So actually, fog cloud is a term that we use for there is we don't know the there is disruption within the cloud services function. Although the concept still valid for core and edge. However, you need to understand the ecosystem of the ecosystem that you're going to apply, or the environment that you're going to need. It still depends on the architecture that you're going to implement, the hierarchy architecture, especially the networking architecture, the network architectural level on that. So yes, it's still valid.
Ayan, thank you, sir. From Sir Samuel, how can I build my own data bank using cloud and edge computing po? Thank you.
How I can build data bank using cloud and edge. All right. Okay. So actually, if you're going to build your data bank, it depends on your need. You don't if your application doesn't require you to use edge computing to do the computation within your certain area or locality, then you don't need to use edge. Again, edge is actually expensive than cloud, because on edge you're going to deploy a edge component or edge server, which are actually AWS and Azure are offering. But these are raw data servers. I mean, you're actually going to use a machine, an actual machine with a virtual machine running on it, and then you have the capacity to enhance this servers. It's like having a data center within your cloud service, but deployed on a local area. Let's say, for example, in the Philippines, if you're going to create an application that requires you to build a face recognition. So face recognition itself has a huge data. And it's actually not just huge, it's a big chunk of data since it's an image. You need the face recognition to respond within a certain limit, let's say 3 to 2 seconds. It should reply that this person is their person. So it's like tagging a person on Facebook. It's like tagging a person with auto tagging a person from your post on a picture, right? So with that, we need to have a cloud server, an edge server that do the analysis of the image and then get those information on cloud. So it still depends on your requirements if you really need it. If you don't need edge computing, and if you don't need real time, if you don't need faster latency, and if you can, since actually cloud computing can manage the latency that you are experiencing, although you need to expand it. From edge computing, you just need to have a server standby catching this information and then fetching the records from the cloud and then processing it on edge and then throwing it back to the user. So yeah, sorry for the long explanation.
Ayan, thank you, sir. And another question po, to be able to say that I'm doing cloud computing, do I need to be subscribed to AWS, Azure, or any cloud services po?
All right. Yes, you need to be subscribed on any cloud service provider. In any case, you cannot have a cloud computing that is residing on a data center within, let's say, within the Philippines itself, since it is just residing in the Philippines. If you want to do cloud computing, you need to have multiple data centers from different region. So let's say you have data center from Southeast Asia region, you have data center from South Asia, you have data center from the Pacific, US Pacific. So you need to have different data centers for you to be called as a cloud service. So yeah, you need to be subscribed on a cloud service provider to be called a cloud service user.
Ayan. I think, sir, siguro last 2 questions tayo para makapag-proceed na po tayo sa ating discussions po. Ayan.
Okay.
So please cite some institutions that are already using edge computing in the Philippines, and does the government agencies use as cloud computing database po?
Actually, good question. Does the government uses cloud computing? Right now, I am not aware if they are using cloud computing. However, some, if not most of the websites of government agencies are within the Philippines network. What sample that are using edge computing is actually, if you're using your iPhone and you're using face recognition, that's one sample of edge computing. They are using edge computing already. What else? Google, they do have an edge computing. They are actually using edge computing in the Philippines. Same goes with Amazon. They do edge computing in the Philippines. That's more on the data caching for their end user. For Google, it's more on the browsing. If you're familiar with SEO, it's more of the SEO data from their browse or internet searching.
Okay, thank you, sir. I think last question po, can we use cloud or edge computing in areas where signal reception is poor, like 3G to barely 4G range po?
Can we use cloud? Actually, that's one great use of cloud computing. If in your locality, let's say, for example, in your local area, you're just having 4G or 3G, if you can bring in edge computing within that locality. Let's say, for example, you have an application that's running on your mobile phone, and then you need to call on a certain service within your application on your locality. You can use edge computing, and then with that, the latency is shorter since it will be going to your edge computing server and then going back to the user.